All right. Good morning, everybody. I see folks settling in. Got plenty of space up at the front here, too. All right. Well, I'm going to go ahead and kick us off. I'm excited to welcome everybody to Evolving Serverless Architectures. So just to get us started, we are going to be delivering a 300-level talk today. So I want to start off with some of the assumptions that we're coming into it, just assuming a little bit of pre-knowledge that folks in the room today have. My first assumption is going to be that you are the type of person that has built a serverless application in some capacity. And through that, you become familiar with the core set of serverless services. So things like Lambda, step functions, Event Bridge, API Gateway, DynamoDB, SQS. You have some familiarity and have built with these services before. Maybe you're even already running a serverless application in production. And so that application, because you've built with serverless services, is highly available, it's scaling automatically, and because you're offloading operations and only paying for when that application is running, you're able to take advantage of a lower total cost of operations. Total cost of ownership, sorry. So you might be thinking at this point, we're done, right? We've got this application shipped, it's providing business value. What more is there really to do for this application? Now, anyone that's run an application in production is going to be familiar with the fact that your application is never truly done. So maybe the product team or the business comes to you and says, hey, we've got a new feature or new something that the customer is asking for that we need to ship for them. Can we add this to the application? You might have a new SaaS application that the company's using that you need to integrate with, or maybe you acquire a company and you need to start to integrate with their systems. Or lastly, you might be sitting here at an AWS Summit or at reInvent and hear about a brand new AWS service or feature that you've been looking forward to and that you really want to start to build with. All of these are reasons why you might want to continue to evolve that serverless application that you've already built. So fundamentally, I'm sure many of you are familiar with the fact that applications really don't stand still. And so today's talk, we're going to talk a bit about how your application can continuously evolve and some of the patterns and real-world use cases you can be thinking about when you want to look at that application and keep it moving forward. So who you're going to hear from today, I'm going to start us off. My name's Emily Shea. I lead our application integration go-to-market team here at AWS. So I and my team work with some of the largest AWS customers on a lot of the integration services that we're going to be chatting about today. After this, I'm going to hand over to Tom Collins. So Tom is a principal software engineer at the Driver and Vehicle Licensing Agency, and he's going to talk about how some of these patterns are in use at DVLA today. So I'm going to start off by laying a little bit of groundwork with this pattern catalog. So this pattern catalog, across the top here, we've got a number of different reasons why you might want to evolve your application. So things to keep in mind when you want to say, hey, I think this application could continue to evolve and we should change things about it. And then within that, I've got a couple different patterns. I'm going to focus on just one or two of these. And these are examples of patterns that you might apply to continue to evolve that application. So this first one is around leveraging platform capability. And what this means is taking something that you might have previously been building yourself and offloading that to an AWS service or a feature. This first one is around taking where you might have been manually sending a message, so writing some code to send a message, and instead pushing that to DynamoDB streams. And I think this one is helpful to illustrate with an architecture diagram. So here's our architecture diagram for this. In the previous architecture, you have a Lambda function that is updating an item in DynamoDB. And once it completes that, you want to then have that Lambda function put an event onto the Event Bridge event bus. And here's how we might evolve that. So we have a Lambda function, it's still updating DynamoDB, but then we have DynamoDB streams turned on, which automatically sends an event and puts that via Event Bridge pipes onto the event bus. Now, to understand why this is an evolution and a simplification, let's take a look at the code that we'd be writing to accompany this. So here's our Lambda function. Now, at the moment, we've got a lot of code in there for putting that event onto the Event Bridge event bus. This is adding some tight coupling in the system to Event Bridge as the only way that we send messages. Otherwise, we need to go back and refactor that code. Another thing in here is that we don't have any transactional integrity. And so if we update DynamoDB, something goes wrong, and we're still sending that message. And so downstream consumers that might be looking for the updated item in DynamoDB, they might encounter some issues. So here's the simplified code once we've evolved that to just use DynamoDB streams. We've reduced that coupling with Event Bridge, and now we have that transactional integrity of DynamoDB is always going to, when it's updated, it's always going to put that event into DynamoDB streams and rely on that to send the event. Also, there's a huge simplification in the code that we're maintaining and writing tests and operating. So this is the first pattern. There's a couple other ways that you could take out some code and instead put that into a feature or service. So for example, going from sending messages to using Lambda destinations is another example of this one. The next category in our pattern catalog is keeping pace with AWS capabilities as they evolve. And so a big one around this, again, I'm going to jump back into the architecture diagrams, is replacing functions that you had previously with just a direct SDK call. So here's a big example that I heard from a lot of customers, especially right around reInvent last year. They were building generative AI applications with step functions. This one has us pulling an object from S3 and then having a Lambda function that calls out to the Bedrock API and then updating a DynamoDB table. Now you might have built this yourself in the past. And then last reInvent, step functions added an optimized integration with Bedrock directly. So now you're no longer needing to maintain that Lambda function code and you can just use the direct API call. The next section of the pattern catalog is your application needs evolve. So I don't have an architecture diagram around this one because I think it's fairly straightforward, but this is where your business requirements or the business logic that you're writing, it evolves beyond what the architecture pattern that you had in place was before, and so you need to make that change. One example of this is maybe you're building an application that has object storage that is meeting the current needs, so you're just using S3 and pulling up files and pulling that data out. But then maybe the application increases in complexity, and you want to then move to something like DynamoDB, so adding a database with some higher functionality for storage. So there's an example of how your application needs might evolve. And the last one that I want to spend a little bit more time on is this concept of improving runtime characteristics. So improving runtime characteristics, this one is all about finding areas in your architecture that you could maybe increase the cost effectiveness, reduce the latency, or overall just make improvements that make the architecture better. And the concept that I want to focus a bit on in this one is choreography and orchestration. So to demonstrate a little bit about what choreography is, choreography is all about having multiple services within a system that communicate exclusively via asynchronous events. The cool thing about this pattern is that you get a very, very loosely coupled system. So if you're working on service A and service A can scale up without having any impact on service B, and the team that's working on service A can be building features and shipping new things without any impact on the team that's working on service B. So very helpful for when you have a very large organization, a very distributed system that you want to be able to build independently around. Some of the challenges that come into play with a very event-driven or choreographed system is that it is a little bit harder to reason about what's going on in the system. It can get very complex, and it can be a little bit harder to maybe do some monitoring or some error handling about all the different events that might be flowing in the system. For this reason, we see some customers that will instead take pieces of their application and move to more of an orchestration type model. Now, orchestration is the opposite of this choreographic approach, where you instead have a central orchestrator, in this case a step functions workflow, that has very tight control over what's happening at each step of this process. A really common example of an orchestration use case is maybe you're building a booking application, and so you want to be able it very clearly, but you're again introducing a bit tighter coupling and a bit more of a bottleneck of if anyone wants to make changes to it, you have that central orchestrator. So what I've observed is that customers will often use a combination of the two. Maybe for a larger system where you've got multiple teams involved, you might lean towards something in choreography. And then if you've got a piece of that system that you want to have a tight control around, orchestration might be a really great fit for that. And you could easily have an application that maybe starts in orchestration and moves more towards choreography, or maybe starts choreography and you say, hey, actually want to take a piece of that and move that to orchestration. But this is a common way that you might think about how do we make this architecture design better to be able to support the needs of the application and the teams that are working on that application. So with that, I will wrap up this kind of intro section around the pattern catalog, and I'm excited to hand over to Tom, who's going to take us through some of the real-world use cases and applications of these patterns at DVLA.
Great, thank you, Emily. So you heard from Emily about all of the great patterns that we can use to evolve our serverless architecture. I'm going to talk about how we're putting some of these into practice at the DVLA. So for people who aren't familiar with the DVLA, we're part of the UK government. We maintain the national records for drivers and vehicles. We collect over 6 billion a year in revenue, and we were early adopters of public cloud. And today I'm going to end with some examples that link back to the catalog. But first of all, I'm going to set a bit of context around the system that we're going to use for the examples, which is our serverless application processing platform. This is primarily based around step functions, and I'll talk about how we're using that there. I'm also going to cover how we've set up our organization to allow developers to innovate and evolve our architecture whilst balancing the sort of governance and security controls we need in place to protect the data that we value so highly. Whilst the focus today is on serverless evolution, technology evolution isn't a new idea in itself. And it's useful to look at this through the perspective of the driving license, which can, if you go back in time, we used to look after driving licenses on paper. We then moved to early computers and punch card systems. We moved into mainframe. We then moved into a sort of photo driver card. We moved into on-premise systems, then into legacy cloud, before ending up where we are today on modern cloud. The change has been natural through that time, but what we find in modern cloud, using so many cloud services where the level of innovation is higher than ever before, there are constant opportunities to improve your architecture and evolve your services. So we're currently modernizing our drivers' services, and that's what I'm going to focus on today. If you're a driver, you may be familiar with this lovely looking service. This is a legacy driver's service. It currently runs on our on-prem technology. This is legacy technology, it's dated, it's difficult to adapt and evolve to meet business needs. We're not able to make best use of modern cloud, and we're not able to use the sort of modern engineering and development practices we'd like to use. So we're working to modernize these systems. It's more than just a superficial change to the front end. We're investing in our identity platforms and accounts. We're investing in new casework systems, and we're modernizing the back end to make it more flexible. And we're replacing the front end with new services that are compliant with GDS standards and look and feel like other modern government services. And at the back end, we're using serverless step functions to model our business process and orchestration. If we look at the high-level architecture, we run a shared container platform, and most of our customer-facing front ends are served on the container platform, which uses EKS. And that's accessed by both customers or citizens, as well as our staff. At the back end, once the transaction's complete, we raise an application in our application processing platform. So we have a multi-account structure on AWS. We have teams who can seamlessly switch between container and serverless workloads, and we have many integration patterns between the workload types. Our application processing system makes heavy use of Lambda, API Gateway, DynamoDB, and step functions. From there, we're able to integrate to other services and utilities, whether they're in the container platform, other serverless accounts on AWS, or even into other clouds and other third-party systems. This really allows us to use the best of cloud and make great use of step functions as a process orchestrator. So our application processing system is really a long-term strategic investment for us. We're currently processing over 1.5 million applications per year and collecting over 30 million a year in payments. The initial architecture was launched in 2021 and supported a single transaction type. We were able to move to a version 2 architecture in 2023. Initially, we were learning how this pattern worked for us and evaluating the suitability of this for complex digital processes. Once we gain confidence in the pattern, we look to evolve to a version 2 architecture that took the learnings and allowed us to have a cleaner separation of concerns and a system that was capable for scaling to meet our needs across many transaction types. When we think about evolution, you won't often get the chance to re-architect your system. Typically, a system will be in place and you might have to evolve it as it stands. The point I want to make with this is that if you get the chance to re-architect, you want to maximize it in terms of the changes you can make to your system, okay? In our case, moving from version 1 to version 2, we not only optimized our component separation of concerns and our deployment model, we were able to use this opportunity to evolve to our new organization-based account structure, which was a big strategic move for us. Typically, a change like that is complex. You may have to change all of your integration patterns and your connectivity between accounts. You may have to migrate data between accounts. So this is something you're not going to do. This sort of evolution isn't something you're going to do frequently, and it's something you really want to plan around. So on this theme, I think it's useful to think about the types of strategies and triggers that will cause you to evolve your architecture. The most common one, and you may have a backlog full of these, is functional change. In our case, it may be that we want to allow users to upload a photograph to be used on their license, and this requires us to perform some machine learning for face recognition and process the photo. This causes obvious architectural change, and it's quite easy to justify functional change, right? There's an immediate business value, and stakeholders, people who are funding you, it's very easy to support functional change. You have to do it. The next type of change, which I would call unavoidable, is also quite easy to justify. So a great example is the way that Amazon deprecate old Lambda runtimes, right? And this is a real positive. It causes you to update to new versions. If you're using nodes, you'll have to keep updating your node runtime to the latest long-term support version. And you can't easily say, no, I'm not going to do it. You can try, but Amazon are going to keep moving this thing on. And that's a real positive. And you're going to end up having to do work and evolve your architecture to meet changes that you can't control. These are generally low complexity and add a lot of value in terms of security. The third type is probably the most exciting, the most interesting. You heard from Emily a lot of the patterns around optimizing your architecture. The rate of change in serverless and integration patterns and new services is very high. A great example is something like event bridge pipes. You may have a system that's using, you're using DynamoDB streams and you've got a Lambda. Event bridge pipes comes along and it allows you to simplify and optimize your architecture. This has huge benefits operationally and in terms of maintenance and possibly a cost benefit, but may be difficult to justify, right? You're unlikely to have a backlog that's full of purely of optimization work, and it's quite hard for, maybe your stakeholders don't want you to spend all your time doing optimization, but you want to be doing some of this. And then the fourth type of change is the one I covered earlier, which is strategic. These are generally high complexity. It's going to require a lot of work, and you maybe need to do a lot of planning, possibly over a number of years, to move towards your strategic goals. When you think about evolution, you don't want to be working in just one of these rows. You want to be working on a balance of work types. Ideally, you've got a short-term and a long-term view. So in the short term, you might be doing functional change, but on a longer term, you want to know over a number of years, where are you going? What are the strategic goals? And balance simplifying your system whilst delivering functional change. So going back to application processing. At the heart of this system, we're using step functions. We chose this to allow us to use an orchestration pattern to implement complex business processes. In our case, it allows us to do things like settle payments, process photos and manage image retention, raise casework, notify customers, and also model how we interact with things like photos being reviewed or allowing customers to replace photos. These are quite complex business processes. Using step functions allows us to visualize this. It's easy to view the state of an application and see what's going on with the process. Step functions provide a managed workflow service. It's a visual service. We evaluated options of running our own service or building something. Being able to offload the operation of our workflow engine to AWS has huge benefits in terms of cost and security and operational overhead. It's also a platform that's constantly evolving. So whenever new services come out, they're either supported directly through the SDK integrations or through optimized integrations, and the service itself is constantly evolving with new features. Okay, so I've mentioned photo processing a few times. This is one of the complex business processes that we're able to model within step functions. In our case, we want customers to be able to take a photo on their mobile phone, upload it with their application. We will then review the photo, we'll process it and prepare it, maybe crop it, and then if it's appropriate, we'll issue it on your photo license. If it's not appropriate, we'll let you know and give you the chance to try again. To support this, we've built a serverless image service, and we make use of S3 object events to invoke Lambda. From there, we're able to call out to Recognition, which is a Amazon managed machine learning service. And that's able to detect the presence of faces and other objects in the photographs that are uploaded. It provides us data on where the faces are. We're able to use this to both validate and crop the photo for inclusion on the license. Once we've done all this work, we output the photos into S3, and we're able to associate that with an application and then include that later on in our business process. So our staff, every photo that gets uploaded, our staff will ultimately review. So whilst we use data from machines to help us, the final decision on the suitability of a photo is made by a human. We're able to build internal user interfaces that support this and interact with the step functions process. So the photo process itself has a number of points that involve humans, right? So for example, if you upload your photo on a Friday, it may sit in a queue ready to be processed the next week when people return to work. If your photo is rejected, we'll let you know why it was rejected and ask you to provide a new photo. You may not respond to that for several days, right? Maybe you don't see the email and you're on holiday. There may be days or weeks that pass before that next interaction. Step functions allows us to model this sort of human process through the use of callbacks and tokens. So this is great. Traditionally, you might use something like a polling mechanism or something to check the status of work that needs to be completed. Within step functions, the task token model makes this sort of process very simple to implement. So in this example, we focus on the review stage. So once the step functions process reaches the review step, we're able to pass information about the application and photo to a Lambda. So in this case, we're passing the type of photo, the application ID, and the task that needs to be complete. The step functions runtime will generate a token for us, which we also pass to the Lambda. And this is generated automatically, and you can pass it from the step functions context into your Lambda handler. The token itself is just a string, looks something like that. And you're free to do with that as you please. You can persist it in another system until you're ready to use it again. You can pass it out to a third-party system. In our case, we'll pass it off to our casework system. A case may take several days or weeks to complete, at which point we can use the token to continue the business process. Once the business process is complete, whether it's a photo review or a case, all the integrating component needs to do is pass the result of the business process. In this case, the photo was reviewed and approved and attach the token. So this is an incredibly simple way to model and implement long-running business processes. Once the token is received, the step function process will proceed to the next step and continue. And you can have many of these running in parallel within parallel branches of your state machine. This is a brilliant pattern. Amazon manage all of the operational concerns here. They persist all of the tokens and state data. You only have to pay for your state transitions. So you're not paying for compute time while you're waiting for humans to complete long-running processes. And this pattern also works for machines as well. So you may have a machine process that takes hours or days. You can use the same token pattern for that sort of long-running integration. Okay, going back to our architecture. We have a centralized container platform. Our customers are able to access user interface applications. In our case, we use Ruby on Rails for this. Once you've completed a transaction, we're able to pass the application to our application processing backend. Here we use private API gateways, Lambdas and DynamoDB before invoking a step function. Once we're into the step function world, we're then able to integrate across our services, whether that's other utilities running in other serverless accounts, or as I mentioned, our casework system. In our case, this runs in Dynamics. And we're able to seamlessly integrate between these different boundaries and application types using a number of integration patterns through step functions. For our photo reviews, we build our internal applications using Next.js. This is also hosted on our container platform. Staff access these systems. They're able to pull review items from queues. And at the end of their tasks, they're able to interface with our processing system using API Gateway, passing the token back and continuing the business process. Once we've completed preparing our applications, we've done all the reviews, we're then able to integrate to our drivers application, which is currently running using Natural and AWS, which are some legacy technologies running on mainframe. So here we've got a mix of container platform, serverless and event-driven compute in the middle, with integration to remote and mainframe applications. And this for us is really where we find the best of serverless and event-driven compute and cloud is really in the middle of this middle tier, allowing us to model complex processes and integrating with many, many different workload types. So as you can see, we've got a multi-account architecture with lots of different systems being built. We have lots of teams working independently within their product areas. One of the things we really need to think about is how we allow those teams to innovate. We want to be a place where people can try new things. We want to adopt new features and technology. But we also want to protect our data and build secure systems. And these two things are not always complementary. So we've done a lot of work to set ourselves up with a platform that allows innovation and adoption of new technology whilst putting the right controls and governance in place. So I'm going to talk a little bit about how we do that. The three main themes are use of service control policies, IAM permission boundaries, and IAM resource policies. But before I do that, I'm going to give an example. So I think this is more interesting than the technology. So EventBridge Pipes was launched at reInvent back in December 22. December the 1st, and it had general availability. So this was available to use. Now, we don't want our teams to, without any governance at all, to be able to use brand new features. There's so many services and things being launched. We want to control that. So when this launched, we were unable to use this new feature. But immediately, it had value and potential for us, both in terms of simplification and cost optimization. So how do we get it into place? So all of our services and technology are managed, in our case, through an enterprise technology catalog. This dictates where things can be used, whether they're in a trial phase or an adoption phase, and documents any constraints we may have. And on December the 15th, so a couple of weeks after reInvent, we raised a request to trial pipes within a particular context, in this case, the application system. At this point, whilst it was approved from a governance perspective, we still weren't able to use it because our policies are managed through infrastructure as code. Our platform team, on the same day, were able to respond quickly, and in this case, they permitted the use of pipes within our development accounts. So we still can't use it in production, but now we're unblocked in development to perform technical spikes. And this was 2 weeks after the feature being launched. Christmas got in the way, so we had a bit of a break. But soon afterwards, teams returned to work, and by January the 6th, we had work being undertaken on technical spikes to look at how we can use pipes. In February, once the spike completed, we were confident that it was the right technology. In February, we moved it into an adoption phase. And then on March the 30th, we completed the productionization and hardening of the work, and this was then deployed into production. So we're talking months, 3 or 4 months, rather than days or weeks. But it's still a pretty rapid, we've got all of the correct governance in place. We've got tight security controls around features, but we're still allowing our teams to innovate and move at pace. And I think 4 months for this we're happy with it. If you're working in a large organization, you need to think about security, but please think about how you enable people to innovate quickly. Make sure you've got the processes in place to allow teams to do that. You're going to struggle to get people to adopt new things if they're blocked, or it takes years to adopt new features. And if you look at developer satisfaction, allowing people to use new features within a reasonable time after launch is going to be a positive for you. So how are we doing this? The foundation for our permissions policy is SCP, security control policies. This allows us to restrict accounts and users from doing certain things of infrastructure that we've deemed that we don't want to do. Examples would be to create public S3 buckets. And in the code example here, we've decided we don't want teams to use Lambda function URLs, so we've blocked this. And this gives you a really great foundation because you can give teams a lot of freedom knowing that certain categories of risk are blocked and aren't going to be possible. On top of this, we use IAM permission boundaries. So permission boundaries define the range of permissions that a particular type of resource is able to do. As an example, we have a permission boundary policy for Lambda functions that's different to the policy for step functions. And we're able to decide, for example, a Lambda is allowed to interact with S3, but a step function isn't. And this allows you to create resource-based policies that meet your organization's security needs. Right? You might find out that Lambdas and step functions are quite similar, but you may decide we only want to integrate with this type of service from Lambda. So permission boundaries, they define the maximum range of permissions that a particular resource may have. Within that, we're able to give developers complete freedom. So we've got quite a broad set of permissions. If you're a developer, you can do anything that that permission set permits. It's a public set, and if you want to expand it or change it, you're able to raise a PR, and we can have a discussion about expanding that permission set. Then the final feature that we make heavy use of is IAM resource policies. So we have many teams. We want the teams to govern the access controls and permissions around their services. Resource policies are a great way to do this. It allows you to define very fine-grained access controls between different roles and accounts and teams, down to the sort of endpoint or function level. And we find this works incredibly well for giving team autonomy whilst also allowing a great security position. Okay, on to the examples. So you heard from Emily about a number of patterns for refactoring and evolving your serverless architecture. I'm going to talk through 2 that we've put into place at the DVLA. The first one is around service integrations, and we use this heavily. We didn't use it so much in our version 1 architecture, but we've used it heavily in version 2. There are 19 optimized service integrations from step functions, but there's also something called SDK integration, which effectively allows you to use the entire AWS SDK within your step functions design. Typically, you might, if you're not using service integrations, you might have a Lambda that's quite complex and is doing several things. Maybe there's some logic and decision making. Maybe you're calling out to a service. By breaking your design down into discrete service integrations, you not only allow the logic to be visualized, so you can follow it visually within the step functions workflow editor, but you're also breaking down each operation into a discrete function. And they're a lot more easy to reason with and test. And the way that they're retried, so step functions can automatically retry each step for you, becomes a lot more easy to reason with and maintain. Within the workflow editor, you can search for any of the AWS services. It'll return all of the operations that are available to you, and you can drag and drop them into the workflow editor, which is a brilliant pattern. Once you've selected an operation, you're then able to configure the parameters that you want to pass to the operation. So in this case, we have a DynamoDB put operation, and you're able to specify the data from the step functions context that you want to pass into that operation. So if you're doing this for a Lambda, you've got to pass the data from step functions into Lambda, and then from Lambda into DynamoDB. So you've got 2 points of failure there. This really, really simplifies and reduces your error rate and gives you a much better operational posture. So in our case, whenever we start the step functions process, we want to store some data in DynamoDB about the execution. Previously, we were doing this for a Lambda. And it's fine, it's not a particularly complicated Lambda, but every Lambda you have, well, it's going to add to your build time, it's going to add to your operational overhead, it's going to lower your developer experience, and it's more code to maintain. We're able to refactor this, we're able to get rid of the Lambda entirely, pass exactly the same parameters from the step functions context into the step functions configuration, and remove a Lambda. And we've done this in dozens of places, which really speeds up our build time and optimizes our system. It increases developer satisfaction and makes it much more easy to reason with what your business processes are doing. Second example I want to cover is around event bridge pipes and our transactional outbox patterns. So you heard from Emily earlier how you might want to use DynamoDB streams with event bridge pipes, and this is a great pattern for supporting sort of transactional integrity. In our case, we were already using DynamoDB streams, but prior to pipes, we had a Lambda function consuming the stream. So when we update a task or complete something like a photo review, we want to update the task data in our task service, and we also want to store one or more events. The events, in our case, we want to send them onwards to our data platform. We use a single table design and update this within a transaction operation, so our functions are doing a single atomic update. This data is then, because we've got a single table design, all of the records are combined in the DynamoDB stream. So we've got updates not just to the task item, but also to the events. And in our case, we're only interested in the events. In our original architecture, we had a filter function, consuming the stream, writing the event, filtering out the events and passing it on to Kinesis. And the Kinesis stream simply contained the events. So we were able to replace the Lambda function with pipes. The original design, the function was responsible for not only filtering the events, so filtering the stream, we want to reduce it to just the events. There was also a little bit of transformation, and then we also had to send the events on to Kinesis. So there were three different things going on in the code. Pipes has this very same model, but allows you to configure it purely as infrastructure as code without having to run a Lambda. So with pipes, you're able to specify a source, in our case, the stream. You're able to specify a filter, so you can express an object pattern that will filter your data, and Amazon, the pipe service, will run this and operate it for you. You don't need to write any more code than the pattern you're looking for. And you can specify a target. And pipes will consume the stream automatically, do the filtering, and then send on to the target. This is great. It's going to simplify your operational overhead. It's another Lambda that you don't have to build. And it's another service you don't need to run. In the refactored design, we're able to get rid of the Lambda and replace it with pipes. It's a small change. It wasn't particularly complicated. but has significant benefits for us. We use this pattern in a number of places. We've removed several lambdas, and we have a single managed service for this sort of point-to-point integration. The main benefit for us is operational and around sort of consistency of the pattern. It's also useful to think about cost benefits, but this is often a little bit more difficult to reason with and isn't often the main motivation for us for making this sort of change. If you want to think about costs, you need to look at what's the cost of the Lambda. So that we had a Lambda, it consumed 100% of the events in the DynamoDB stream. We're only really interested in half of them, so there's a lot of work there that doesn't need to be done. With pipes, you do not have to pay for events that you filter out. So in our case, we can throw away half of the events in the stream that we're not interested in, and there's no cost. We're only paying for the invocations onwards from pipes, which is great. In our case, pipes works out to be a cost saving. Depending on the amount of compute and work you're doing in your Lambda handler, that may not be the case. I encourage you to analyze and investigate this in some detail. And in terms of code, we're able to go from a Lambda function that performed filtering and sending onwards to some configuration for pipes, where all we're really interested in is expressing the filter. And this is a massive simplification. Okay, so in summary, key points for me are you want to regularly consider how to evolve your services. You want to be looking at this on both short and long term. You want to enable innovation and evolution. You also want to think about strategy. Move towards managed services. So shifting your operational overhead to managed services and managed integration is going to have huge benefits and simplify the workload for your development teams and simplify your architecture. And make sure you're set up to support evolution. Think about the security position you need to be in and that you've got the right policies in place, but also don't prevent people from innovating at pace. Okay, that's all from me. Thank you for listening. I'm going to hand back to Emily.
Thank you. Wonderful. Thank you, Tom. Excellent. Well, thank you so much to Tom, and I so appreciate the opportunity to get a peek into a real-world system that really exemplifies a lot of these patterns, especially a system that many of us are probably familiar with interacting, so super cool. Just to end off, there are so many different reasons why we might be evolving our serverless architectures, and I really hope that you've come away from this talk with some ideas and some inspiration for how you want to go back and evolve your serverless applications. So thank you so much from Tom and I, and we would love your feedback, so feel free to give us a survey, but thank you all.